Good afternoon, everyone, and welcome to session number 33. Our topic for today is production geoscience. And so we have focused a lot of the course on the exploration stage, and last week I talked a little bit about development geoscience, and today we'll talk about production. So I have talked already about an asset's life cycle. We have to capture an opportunity. That's usually through some sort of a lease sale or arrangement with landowners. People in geoscience that worry about new opportunities are in groups that are called new ventures. We obtain some licenses. We do our exploration. Our goal in exploration is to discover hydrocarbons. We will then turn it over to people that worry more about development geoscience. They want to initiate production, and then it gets passed into the production department or company or group, and they worry about depleting the field. So trying to get as much oil or gas out of the ground at a profit for however many years the license extends for. So this is what I showed on the first slide. So we're going to focus today on production. And in terms of the scale of our analysis, we have really zeroed in, and we're looking at compartments within the reservoir, zones or intervals that are going to produce differently from neighboring compartments. And some of those compartments will be separated vertically or stratigraphically. Sometimes we talk about zone A, zone B, zone C. Another way the compartments can be set up is by the structuring, the faulting. And so we may have a high side of fault A, we may have a high side of fault B, we may have high side of fault C. So when we're in phase 4 production, our main objective is to try to maximize the production and to hold down our costs as much as possible. So we're looking at compartment scale studies. We may need high resolution seismic data, and I have a couple of examples of that. We want a detailed map of our reservoir compartments. We may be able to use seismic attributes to extract more and more quantitative information about how the field is going to produce. I'll talk a little bit about time-lapse seismic or 4D seismic, where we use repeat seismic surveys to try to monitor how the field is being flushed of its oil and gas. We will try to build a reservoir simulation and calibrate that using our production history. We are always looking for new pay zones, portions of the reservoir that we're targeting that perhaps we haven't been able to drain. And we also are looking for other opportunities, maybe deeper beneath the field, or maybe they are something adjacent to the field that is a very similar setting in terms of source reservoir trap seal migration. So we're looking for additional reserves. We want to try to optimize our well locations so that we maybe can drill fewer wells and therefore not have as much expense. We may be thinking about trying to use some sort of an enhanced recovery process, injecting something into the reservoir to try to drive oil and gas up the production wells. We'll be reworking and refining and updating our field depletion plans. We want to maximize our production, how much quantity of oil or gas we are producing, and therefore getting to market and selling. We want to minimize the costs, and at some point we're going to have to abandon the field, and we want to know when that time will be. So some of the questions in the production cycle, how should we manage the field so as to maximize our investment? A lot of money has gone into finding the field and developing the field and managing, maintaining the field. So we want to make sure that we're maximizing the dollars of that investment. We may be able to, certainly would want to monitor how gas and oil are being swept out of the reservoir. maybe we're thinking that we can put some injection wells in and inject something into the reservoir in order to enhance the recovery. We're always thinking, is there more oil or gas in the vicinity at deeper depths or in nearby traps? And we want to see if we can build and then calibrate a field simulation model. And if we can do that, then we can take the model and project it into the future. What if we drilled a few more wells at certain locations? How much extra oil or gas and how much money would that translate into? So high resolution seismic data, once an asset has been discovered and we've decided to develop the field, often there's reasons to get better quality seismic data so that we can make better business decisions about how to produce the field and maximize our benefit, our profits. We can get that high resolution either by reprocessing our existing data, or we may have to reacquire new seismic data. So here's an example. The reference from the web is at the bottom. This might be exploration stage data, and this is the more high quality, high-end, high-resolution seismic data. So the next slide will look at the yellow boxes on these two data sets. So on the exploration data, you can see the top of the reservoir is the blue horizon, and the base of it is the gold or yellow or whatever color you want to call that. The data are not too terribly high resolution, good enough to map the top and the base, but not very good in terms of trying to figure out what's going on internally within that interval. This is the production stage data. It looks a little less noisy, a little more consistent, and there actually is a fluid contact right in here, and it's right there. And so you can't see that contact. Maybe once you know it's there, you could kind of say, yeah, I kind of see hints of it, but it's much clearer on the production stage, higher resolution seismic. This is another case. Sometimes instead of getting new 3D surveys, we may just get some high resolution 2D lines. And maybe that would be to connect the different well locations. Maybe it's to connect up portions of the field with more of our regional data set. So this might be an exploration stage 3D seismic survey. And for comparisons, here's a higher resolution 2D line that was shot during the production stage of a particular asset. And you can see that the reds and the blues are skinnier and more continuous, thicker and less, a little bit more wavy over here. So we're getting some more stratigraphic detail out of the higher resolution seismic line. One of the things that we want to do in the development phase is to map all of our reservoir compartments. We can use the existing seismic, reprocessed seismic, or reacquired data. And each compartment in the field is going to have to be mapped and its impact on the production evaluated. So here's an example of a reservoir. It looks like it has 1, 2, 3, 4, 5, maybe a few more, 6 compartments separated by faults. Again, there could be some vertical separation into different zones of the particular reservoir. The contour interval here is 20 meters, so we are getting quite a lot of detail as to the structure of the reservoir. We can also do some more detailed attribute analysis. This is an example from the Gulf of Mexico. There's a gas field. It has multiple pay levels. This is a particular level. This is a fairly shallow one. And the really high negative responses, which are the reds, is an indication as to where the gas is located. So you can map out the extent of the gas fairly easily with this particular seismic attribute. And what we typically would do is we would look for a series of 2, 3, or 4 attributes, try to come up with a way to quantify reservoir quality or percent gas or gas thickness using several attributes. In this particular case, this is a fluvial sand, and so this is the main part of a major fluvial channel, and this is interpreted to be a crevasse splay off of that channel. So a lot of detail once we have the appropriate data and we can calibrate it with some well data. I mentioned earlier time-lapse seismic. Some people call it 4D seismic. This is a case in which we compare several different 3D surveys acquired at different periods of time. So we do acquire a 3D survey after production has started, and we call that a monitor survey, and we'll compare that with a 3D survey that was acquired before the production started. We call that the base survey. And one of the main difficulties with time-lapse seismic is that we want to try to match as best as we can the acquisition and the processing of the data, so that then when we compare them, we are comparing apples to apples. So typically what people will do is they'll subtract the two, the base survey before production minus a monitor survey X number of years after production, and those differences should be due to the changes in fluid distribution. So here's an example from the Gullfaks Field off of the United Kingdom. This is 1985, before production started. We have an oil reservoir at this location. We have a smaller one over here. On the seismic, this big yellow trough dies out, and that marks where the oil-water contact is. And then there's a little bit of yellow over here. You may not be able to see it, but it says OWC down here as well. And so this is what we believe the field looked like before production started. We can compare that with another 3D survey shot 1999, so 14 years later, and although the oil has been flushed out of the smaller trap, we still have some oil in the larger trap, but a lot of the region that had oil in it has been flushed as we've produced the oil. And if we look at the seismic, we get no yellow over here, indicating that there's no oil there presently. And the yellow here doesn't extend as far down dip. And so it's telling us how much oil still remains in this particular trap. And on the little model over here, you can see where the oil-water contact would have been in the year 1999. This is the same survey area. So this is Gullfaks. This is 1985, 1996, 1999, which I showed on the previous slide, 2003, 2005, and what is color-coded is the oil saturation. So there's a lot of oil if it's in the red shades, and there's very little oil if it's in the purples to blues to blacks. And as you look at how much red is on each of these slices, you can see over time that they have been draining this reservoir fairly effectively. We still have a little bit of an oil leg up at the top of the structure, even less here and even less here. So by doing time-lapse or 4D seismic, oftentimes we are able to monitor how the oil is being produced or how the gas is being produced. And if we have compartments that have not been flushed, they would stand out with 4D seismic analysis. Another thing that is common in production stage is to build a calibrated reservoir simulation model. What we want to do is predict future oil and gas production given the existing wells, plus what would happen if we drilled some new wells, some additional wells. And we can drill in the model new producing wells or new injector wells. In order to do this type of modeling and future predictions, we have to build a computer model of the field, and that includes the rock properties as well as the fluid properties. We subdivide the field into cells, and each cell in the model would have rock properties, fluid properties, and other physical properties. So a rock property might be porosity, a fluid property, example of that is oil saturation. One of these additional physical properties, one would be temperature, one would be pressure. We'll build the model based on our interpretation of the rock and fluid distributions, and then we'll use the production history to the present in order to try to calibrate the model. So we work at tweaking the parameters until we can match the historical or known production history. If we can do that reasonably well, we get a fairly good calibrated model. Then we can use that calibrated model to try to predict what would happen in the future, next 10, 15, 20 years, either with just the existing wells, or if we were to drill additional producing wells or additional injector wells. So this geological model, it's an integration of all the geological, geophysical, petrophysical interpretation and concepts that have gone into our analysis of a particular reservoir. So we have our stratigraphic and our structural interpretation, our geophysics, petrophysical information. Here's the structure down here, and we'll build this very detailed model to try to understand what's happening within our reservoir. So these models, they vary quite a bit. They've become more finely subdivided over the years as our computer capabilities, our hardware, our software have improved. But typically a cell within one of these computer models will be maybe 75 meters by 50 meters X and Y, and usually on the order of about 1 meter in thickness. And each of these cells will be assigned a sedimentary phase Gs, a porosity, a permeability, temperature, fluid saturation, pressure, net to gross, et cetera, et cetera, et cetera. We'll take our geological model. We have to upscale it because we can't put as much detail into the computer model as we get from our geological and geophysical data. So we will upscale it to form a reservoir simulator, and then we'll simulate the production from the startup to the present day. And so here's oil production versus production time. And so the blue dots are actual data from the production history, how much oil has been produced as a function of time. And then the red line shows what the computer model that was developed for this field is predicting. And so this is a reasonably good match, not a perfect match, but it indicates that at least we're getting pretty close to what the truth is. So then we can use that. So if we have a field, the alpha field, let's say it's been producing for 5 years, we want to maximize the production. First, we would build the geological model. Then we convert it into a reservoir simulation model. Upscaling is the main step that's involved there. Then we look at the match between the actual production history and what the model is saying. If there isn't a match, then we'll go back and iterate and change the model or the parameters in some fashion. If there is a good match, then we can use our model to simulate future production. And with this simulator, we can add additional wells at certain locations at certain years into the future. So to use the simulation, here again is an example. The red is the modeled production to present day, and the green is the actual, and you can see there's a very good match here. And then we can go from present day into the future, and this could be 5 or 10 or 15 or 20 years out. The base case represents the oil production with the existing wells with no additional wells drilled. If we use some enhanced oil recovery methods, injecting something into the reservoir to help move the oil and gas, we can increase the production. And then if we drill some extra wells in key locations, we can increase the production even more. And so the value of these simulators are to do these what if cases. What if I start an enhanced recovery phase? What if I drilled 10 infill wells? How will that increase my oil production? And by having more oil and selling that, will the value of that extra oil be greater than the cost of the program that we put in place in order to enhance the recovery? So that's it for my prepared remarks. I'll turn the microphone back over to Dr. Sumi and see if there are some questions about today's topic or something that we have covered in the past.
Great, thank you so much. So yeah, as Fred mentioned, you can put questions into the chat box. If there's anything that you have to ask them about this webinar or any of our previous webinars, now's the time to ask. And please feel free to join us for the webinar at 3 p.m. Eastern Standard Time today on technical writing skills and how to put together reports for the oil and gas industry.
Okay, well, I appreciate everyone's attendance and interest in the series.
Yeah. Okay, well, it doesn't seem to be any questions, so we'll see you back here at 3 p.m. Eastern Standard Time for the last webinar in this series. So have a good day, everyone.
Bye. See you in half an hour.
Yeah, bye.
Bye.